Hey everyone, welcome back to another explainer. Today we're diving into a topic that is just absolutely mind-bending. We are talking about planetary engineering, specifically the ultimate extreme makeover, the total transformation of our sister planet, Venus.
To kick things off, there's this absolutely brilliant analogy from the source material. It says, the difference between the sky plan and the surface plan is the difference between renovating your attic while living in it and demolishing your house to the foundation. Keep that idea in your back pocket today, because the sheer, unimaginable scale of what we're about to explore is literally going to change how you look at humanity's future in the solar system.
You know, there's a pretty massive irony when it comes to planetary engineering. For a century, humanity has been completely obsessed with Mars, right? But Mars only has 38% of Earth's gravity, which might not even be enough to raise healthy humans, and it completely lacks a protective magnetic field. But Venus? Venus has 90% of Earth's gravity, an induced magnetic field, and a thick atmosphere that already provides massive radiation shielding. Venus actually has the right foundational bones for human survival. But, yeah, there's a pretty massive catch.
Okay, let's dive into this. Section 1. The Millennial Surface Plan. Basically, a total brute force approach.
So, the terrifying reality of the Venusian surface right now is that it sits at a bone-crushing 92 bars of atmospheric pressure, and the temperature is around 470 degrees Celsius. So if we take that demolishing the house approach we just talked about, here's our to-do list. We have to drop the temperature by a whopping 455 degrees. We have to somehow reduce that crazy pressure from 92 bars down to just 1. Oh, and we need to add an entire ocean. The sheer, daunting scale of trying to fix the surface directly is just paralyzing.
So how would you even attempt this? Well, the mechanics of the leading surface method requires space-based manufacturing on a scale we can't really even comprehend yet. Step 1, you build a 12,000-kilometer sunshade out at the L1 Lagrange point just to block the sun. Step 2, you wait for the planet's entire CO2 atmosphere to freeze out into dry ice. Step 3, you bury hundreds of meters of that dry ice or try to chemically convert it. And Step 4, bring in massive amounts of water. I mean, just building a Venus-sized sunshade. That alone is a wild multiplication of our current industrial capacity. And if you think building it sounds rough, let's walk through this timeline. We're talking 50 years just to build the sunshade. Then, 200 years for the atmosphere to freeze out because CO2 holds on to heat incredibly tenaciously. Then another 500 years just to remove all that dry ice. And finally, 1,000 years to seed a functioning biosphere. The whole process is painfully, agonizingly slow. And that brings us to this big number, 1,500. 1,500 years is actually a realistic, conservative estimate to finish the surface plan, factoring in inevitable delays. To put that into perspective, 1,500 years is roughly the amount of time between the Norman conquest of England and today. It's a really long time.
But wait, because there's a massive hidden challenge here. Venus doesn't have an intrinsic magnetic field like Earth does. So let's say you spend 1,500 years building this beautiful, breathable, one-bar atmosphere. Well, the solar wind is just going to immediately start stripping it right off into space. To fix that, you'd have to build an artificial magnetic shield, which tacks on another 100 to 200 years to our already bloated timeline. It pretty much proves this brute force method is almost impossibly flawed for any civilization to actually pull off. Which brings us to what I think is the most absolutely crucial question of this entire explainer. Do we even need to fix the surface? Seriously, take a second and really think about that, because this one simple question flips the whole planetary engineering problem completely on its head.
That brings us to Section 2, the Skyworld Paradigm Shift, or as we called it earlier, renovating the attic.
Now, enter this revolutionary plan developed by actual planetary engineers that completely bypasses that hellish surface. Because, as it turns out, exactly 50 kilometers up in the Venusian sky, the planet simply ceases to be a hellscape.
Right at that exact 50-kilometer altitude, you hit perfect Goldilocks conditions. The atmospheric pressure drops to exactly 1 bar, which is the exact same as Earth at sea level. The temperatures hover between a super comfortable 0 and 50 degrees Celsius. You are safely above all the deadly sulfuric acid clouds. But here is the most mind-blowing fact of all. Because the atmosphere of Venus is incredibly dense CO2, breathable Earth air, like regular oxygen and nitrogen, actually acts as a lifting gas. A habitat full of the exact air you and I are breathing right now would literally float in the Venusian sky like a giant blimp. How amazing is that?
So how exactly do we build this attic? Well, it starts with a 30-year robotic construction phase. First, probe airships map out the sky. Then, robotic factories move in using all that abundant solar power to break down the atmosphere, which, remember, is 96.5% CO2. They break it into pure oxygen and solid carbon. And then, they weave that carbon into carbon nanotubes to construct a continuous planet-wide shell. Venus literally provides the exact materials we need to build the biggest structure in human history, right out of thin air. And sitting directly on top of that massive carbon nanotube shell, you have the cloud continents. Picture this: massive, interconnected floating platforms with entire cities, parks, even lakes. These are completely sealed habitats, suspended by extracted nitrogen gas and resting securely on that tile layer. And the truly brilliant part of this whole plan? That carbon tile layer acts as a permanent lid, forever sealing away the 470-degree nightmare down below.
But as always, there's a catch. Section 3, the fatal flaw, the water deficit.
Here's a comparison that gives you a real sense of scale shock. If you took all the water on Earth and spread it out evenly, our oceans would average 3.7 kilometers deep. But if you took literally every single drop of water in the entire Venusian atmosphere and condensed it onto the surface, it would form a global puddle exactly 3 centimeters deep. That's it. Local water extraction on Venus isn't just hard, it's completely impossible. So, what's the awe-inspiring solution here? We just have to import it. Using highly advanced plasma propulsion tugs, we'd go out and redirect comets and icy asteroids from the outer solar system, places like the Kuiper Belt, and steer them into controlled impacts right onto our new planet-wide shell. We'd basically slowly rain comets down onto the tile layer. The kinetic energy flashes all that ice into steam, and eventually it condenses to create the very first Venusian oceans.
Now, let's look at the timeline for this Skyworld plan. Year 10, robotic factories deploy. By year 40, the tile shell actually closes around the planet. Fast forward to year 120, and those cloud continents become habitable for colonists. And by year 200, we've got open-air agriculture. When you compare that 200-year timeline to the 1,500-year brute force plan we talked about earlier, the math is just astonishing. Theoretically, people born today could actually live to see the very first cloud habitats established.
So the crucial point is, Section 4, the ultimate human challenge. We clearly have the underlying physics to make Skyworld a reality, but do we have the society to pull it off? Let's just neutrally break down these immense hurdles for a second, because they are huge. First up, scale. Building a 460 million square kilometer shell requires a multiplication of our industrial capacity and energy that we just can't fathom yet. Second, biology. We'd have to design a perfectly closed ecosystem, and history shows this is incredibly messy. Just look at how Biosphere 2 failed here on Earth. Ecology is way messier than physics. And third, humanity. Could any human civilization maintain a coherent, unified political and economic commitment for 200 years? Honestly, politics might be the messiest hurdle of the whole shebang. And I think that brilliantly illustrates why this quote from our source material is so profoundly beautiful. It says, "Perhaps a terraformed Venus would be a cathedral on a planetary scale, begun by one civilization and finished by another. Just like the grand cathedrals of Europe or the Great Wall of China, this would be a multi-generational masterpiece, built by people who plant trees fully knowing they will never actually sit in their shade." Which leaves us with this final lingering thought. We know the physics. We know that exactly 50 kilometers up, Venus is just waiting for us with perfect pressure and temperature. The question isn't whether we can, the question is whether we will. Thanks for joining me on this explainer, everyone. Keep wondering, keep learning, and I'll catch you on the next one.